Hello friends, welcome again to this channel. So today let us have the phasor diagram of voltages and currents. So these are the things that we will discuss today. Phasor diagram. So the voltages and the currents in an alternating circuit can be shown on a phasor diagram. So you can represent your voltages and current through a diagram, and we call this as phasor diagram. So these quantities are represented by directed line segments, which is drawn from the origin. For example, here is my y and x axis, or my x and y plane. So now the x axis is referred to as the real axis, okay, and the y axis is the imaginary. Okay, so this is the real axis and this one is the imaginary axis. Okay, and by the way, the lengths of these segments can be drawn to a proportion. You just show the relative magnitudes of these quantities. So phasor diagram also shows relative phase positions of these quantities. Now, for instance, I have here a phasor diagram in which this is where my B sub 1 is, and the current is here, I sub 1. Okay, so voltages and currents can be frequently added or subtracted from other voltages and currents. So therefore, I can set up here another ray, okay, starting from the origin, and I can name this as B sub 2. And B sub 2 with respect to B sub 1, or making B sub 1 as reference, B sub 2 can be or can have an angle of theta, okay, and B sub 1 referring to I sub 1 has a 90-degree angle. Okay, so this is how you represent voltage and current into phasors. And okay, so this diagram can be rotated also. You can have it like this one. Okay, so here is where my eye lies in the x axis. I make this as my eye. That is my eye. From considering this phasor representation, so my V sub 1 goes here. So this is where my B sub 1 goes, and the B sub 2 will goes here. B sub 2. Again, this is theta. Okay, so this is actually this representation or diagram has been rotated. I rotate it from I1 and place it here. So my I1 is from 270 degree, and I place it at 0 degree, so I rotate it at 90 degree. I rotated at 90 degree. Okay, so this is a very important circuit analysis tool. because this diagram is a visual representation of the circuit quantities. By the way, the relative magnitudes and phase positions are all shown on this diagram. Okay, so take note that analytical solution can be very difficult to obtain for some problems, but a graphical solution based on the circuit diagram can be used instead. So we can facilitate solving problem by using a Phasor diagram. We will just use the trigonometric functions and formulas to solve the parameter that we are looking for. And now we also have the power in alternating current. When we mean power, okay, so this is another topic in AC circuits. Again, when we mean power, we mean the multiplication of the voltage and the current. So we can know if the part of a circuit is a source or a load. So if we are representing that circuit in a rectangular box like this one and have it named as AB for nodes A and B, and this has a polarity of positive, okay, and this one is negative, and this is the voltage polarity, and our current is going there to the left side. So we know that this element is a source because the source gives off current, and current comes out in the positive polarity. But if our rectangular element, which we do not know if it is a source or a load, again this is positive and this is negative for our voltage, and the current is going out from the negative polarity, it means that this element is absorbing an energy or dissipating power. So this is a load. Okay? So these are the things that you should know with regards to the power in an electric circuits. So now if we have B sub AB named as B sub M, the maximum value sine omega t plus phi, and our current, again same as the voltage, the maximum value sine, again omega t plus phi, and there is an angle theta which is subtracted from omega t plus phi. Okay, so if you are going to get the product, we just multiply B sub AB times I. The product of that will be the power. Okay, so actually this is the power supplied. Okay, supplied. Okay, now knowing that our B sub AB has this value of Bm sine omega t plus phi, our power from this multiplication of voltage and current, our power is B sub M sine omega t plus phi, and the current is multiplied to the voltage, which is Im sine omega t plus phi minus theta. Okay?